Okay, so we're going to talk about section 1-3, the first part, and we're going to look at measuring segments. So we're looking at the coordinate of a point. So if we have points A and B here, the coordinates are going to be the numbers on the number line corresponding to where the point is. So if I have a point A, the coordinate of point A is going to be the number on the number line 3. So the coordinate of point A is 3. The coordinate of point B is -1. And we're also going to look at the distance between these 2 points on a number line. So the distance is that absolute value of the difference. Algebraically, that's what we're going to look at. So points A and B, if we're looking at the distance, we want to find the difference between those two and subtract, because that's what the difference means. So I take 3 minus -1. So negative and negative gives me a positive, so it's 4. You can also do the difference of B and A, so you can subtract. And the absolute value, that allows us to get the same answer no matter how you subtract it. So you can get -3 minus 1. And the absolute value of -4 is the same as the absolute value of 4. So the distance between points A and B is 4. And the notation for distance just means that you won't have that bar above the letters. That's kind of the new thing. If you had a bar above the letters, you would be saying the segment and wouldn't be talking about distance. So we're going to practice that with our other number line. So if I have this number line and I'm looking at a point on the ray NE, so I go to N, I go to E, an array has an N point at the first letter, shoots out in the direction of the second letter. So we need a point on NE, so all of these, N, U, H, E, all the way in that direction are all points on our array that are 1 unit away from N. Here's the thing. I have to be going in this direction. So the only one 1 unit away in this direction is going to be U. So the only point 1 unit away from N going in the direction to the left is U. 2 points. Now we're looking for 2 points that are 2 units away from J. So let's look at J. So here's J. And we need 2 units away. So I'm going to go 1, 2. And that's A. Then in the other direction, because we need 2 of them, I'm going to start at J and go 1, 2. So the 2 points that are 2 units away are A and U. Last couple questions. Coordinate of the midpoint of EJ. Okay, so I got to find out where EJ, segment EJ is. EJ, somewhere there. Finding the midpoint means finding the middle. Let's say I find out how far I've traveled. So 1, 2, 3, 4 units. So the middle would be 2 units in. So I'm going to go 1, 2, from E in towards the middle, 1, 2. And my midpoint, the point in the middle, is U. So we're using U a lot. Okay, nice. Last question. With this diagram, we need to find the segment congruent to HJ. Congruent means we have the same length. So first of all, I need to figure out where HJ is. HJ. How far have I traveled to get from H to J? 1, 2, 3. So I need it to be 3 units long. So another segment that's congruent, so the same length, 3 units. Okay, so the last question in the section is asking about a segment that is congruent, so the same length as HJ. And we know that HJ is 3 units. One way you can do it is by counting, just like I did it on the diagram, or you can find the absolute value. So you can do -2 minus 1. And that gives you the absolute value of -3, which is just 3. So that means that I need something that's 3 units away. I can count it. So I can go from J to another spot, and it looks like I could probably go 1, 2, 3 and find a congruent segment in JB. If I go from H, 1, 2, 3, I could have HK. And you can also go from any other point. You could also find a segment that's congruent in E all the way to N. So EN is 3 units, 1, 2, 3. And then we're going on to, so we're going to use the absolute value way of finding whether our segments are congruent or not. Because if you look, our number line is now just a bit more spread out. So we're looking at the segments AM and IT and deciding whether they're congruent. So are they the same length? So AM, so from -9 to 2, so -9 minus 2 gives me +11 after I get -11, but the absolute value of that. And then IT, so from I to T, I'm going 5 minus 11, which will give me the absolute value of -6, which is 6. Since those lengths are not the same, that means no, these segments are not congruent. LI, I find L and I find I and I subtract. So -4 minus 5, and the absolute value of that gives me +9. And M to T, so 2 minus 11 is +9 again. So yes, segment LI and segment MT are congruent. And we'll keep going with